So we're going to talk now a little bit more about method design and also the this keyword. So we've talked a little bit previously about method visibility. Visibility determines where your methods can be accessed. So public methods can be accessed basically anywhere. So inside the current class where they're written, or from an outside class, which is also called a client class. These are often called service methods because public methods provide the services that could be performed by an object. Most of our methods thus far have been public because the reason we've been writing them is for outside classes to be able to invoke them. But you might also write private methods, and these are methods that aren't meant to be invoked by an outside class, but are really intended to just help the tasks that need to be accomplished internally. So these are often called helper methods or support methods. And again, these are never meant to be used by an outside class, but they're really methods that you just write to kind of support the actions that you need to take within that class. So when you think about how to break up your methods, you want your methods to be relatively small so that they can be understood as kind of a single entity. Remember that our methods represent the actions or tasks that can be completed by an object. So you want your method to represent that. So in order to represent kind of a single task, you really want you would want the method to be reflective of that. So you want it to be small enough to be that. If your method starts to get too large, then it's usually a good idea to break it down into smaller methods. And typically that will involve several private methods that really the only reason you're writing them is to accomplish the overall task, which is being accomplished by the public service method. Okay. So if you are you starting to write a method and it just, again, starts to get too big, or you think you're trying to do too much in one method, it's usually a good idea to break it down. Now, there's no hard or fast rule that I can give you. Once you reach X lines of code, break the method up. It's not that clear cut. It's much more subjective, but it's just something you want to think about, trying to make sure your methods maintain, again, a decent size without getting too big. Now, if you decide you have to break up your method, how to do that is an important decision, and two people writing a program might do it very differently. But when you think about it, there's a couple rules of thumb to follow. One is that if you think you're going to need to do the same thing multiple times, it's a good idea to put that functionality inside of a private support method. So if you ever start to type code that you think, I have typed this exact same code somewhere else in my class before, stop and think about whether you can put that code inside a method so that you only have to type it once. If you need to edit it later, you only have to edit it in one place. And then you can just invoke that method whenever you want the code to run. We haven't necessarily seen a lot of examples of this yet, but this is a good rule to keep in your mind, right? Again, think about any time you're thinking to yourself, I'm retyping the same code or very similar code that I've already typed before. Stop and think about putting that code inside of a method. Again, if your method starts to do too many things, so if you start to think, I have a lot of steps going on here, this method is doing step 1 and then step 2 and then step 3. It's doing a lot of different things to accomplish the overall task. It's maybe a good idea to break that up and put task step 1 into a private method, step 2 into a private method, step 3 into a private method, and then your initial public method will just invoke method, step 1, method step 2, method step 3. And again, this is more of an art than a science. There aren't specific rules I can give you, but these are just things to start thinking about as you start to design more complicated programs. So when we're thinking about method design, let's go back to talking about method overloading. So remember that overloading a method means two methods have the same name but different signatures, and the signature means they differ in their parameter list. So that means they either differ in the number, the type, or the order of the parameters. Remember that we ignore the return type with method overloading. So we're just looking at the same name, but something different about the parameters. And then when one of these overloaded methods is invoked, which version is actually run, and once you invoke the method, is determined by the matching the parameters to the appropriate formal parameter list. So you need those parameters to determine which one will be called. We use method overloading when we want multiple methods to accomplish the same function, but take different inputs to do that. So remember, our classic example of this is the system.out.println method. Sometimes we want to print a string, sometimes we want to print an int, but we don't want to have to call different methods to do that because really we're doing the same thing. We're just printing something to the console. It's just that that something is different. So that method is overloaded so that it's always accomplishing the same task, printing something to the console, but the inputs that we take into that we send to the method rather are different. So that's a good example. Anytime you find yourself wanting the user to think, oh, this is really the same method, I'm just sending in different kinds of information, behind the scenes, you should be overloading that method. So one very common type of method that's overloaded is a constructor. It's very common to overload constructors because you think about there can be different ways to initialize objects. Sometimes you have default values for some of your instance data variables. So if you're going to use a default value, you don't need the user to supply that value. So it's often very helpful to give the user different ways to set up the object, saying, oh, hey, sometimes you can give me all the information. Sometimes you can only give me some of the information. And then for the rest of the information, I'll use a default value. So again, the constructors are doing the same task. They're all initializing an object. That's the job of a constructor, but they're taking in different inputs to do that. So when we overload constructors, the way that we can call or invoke one constructor from another is by the this keyword. And the this keyword actually has two different uses. In general, the this keyword allows an object to refer to itself. So whenever you're inside a class and you want to refer to the current object that is an object of that class, this is the word that does that. So it refers to the current object. Okay? So if you're inside of a method, in the coding of that method, the implementation of the method, and you use this, it basically means whenever that method eventually gets invoked, the object that invokes it, that's going to be the this. Okay, so for example, in my driver program, when I invoked set price with song1, so song1.setPrice, if in my setPrice method, in the actual class, if I had put a this keyword in here, this would be song1. Okay, in this line here where I have my account.purchase item, if I had a this in the purchase item method, so if I put the keyword this here, this would be my account. So it's basically whatever the current object is. When I invoke a method with my account, this is my account. When I invoke a method with song1, this is song1. Okay. So in general, that's what this refers to. But there are a couple specific ways we usually see this used, and one of them is to invoke an overloaded constructor. The second way we usually see this used is to distinguish between instance variables and formal parameters. So up until now, we've been naming all of our formal parameters, things like the new name, the new account number, the new balance, etc. But that's pretty tedious, as you might be noticing, to always come up with new parameter names, and we're just kind of making them, artificially different from the real name of what they are, which is a name, an account number, and a balance. And so what we can do now that we can use the this keyword is we can actually name our parameters, our formal parameters, the same as we've named our instance data variables, and we just differentiate between the two of them with this. So if we say this dot, that refers to the instance data variable. Without the this dot, that refers to the parameter. Okay, so again, this makes sense because remember that this is the current object. So this is saying the instance data variable or name of the current object. So the current object dot the instance data variable name is assigned the value of, if without the this, it's just the local version, which in this case is the parameter. Okay. So we're going to look at an example. We're going to change some code to use this in a moment. But let's just again talk about the second use of the this keyword, and that's to call an overloaded constructor. So if you overload your constructors, you have multiple constructors in your class. And typically what you'll want to do is invoke one of them from the others. So usually what we see is good design practice is that we have one constructor that takes in all the possible parameters that a user might send. So all the information that might describe an object. And then other constructors take in less information, right? Because remember, the reason we're overloading the constructor is we're going to use some of the default values instead of having that information sent by the user. So those constructors don't need to take in as much information. So what we can do is, instead of rewriting code, remember we never want to have to rewrite code in multiple places, we can say, okay, well, I'm going to write the constructor that's the most fully implemented. So it takes in the most information and does everything it needs to do. And then I'm just going to invoke that constructor from another one. And to do that, that's the second way that we can use the this keyword. I think this will make sense when we see an example. So hold off on this one for a moment till we can do it in the code. One other thing about this is that this has to be the first line of the constructor, and you'll see that in a moment. Okay, so let's take a look at using the this keyword in practice. So what we're going to do first is we're actually going to do the second one first. We're going to update the parameters of our constructors and our setters to use the this keyword. So let's go back to our audio item class and let's look at our constructor. Remember, we made up these parameter names: the title, the price, the num seconds. Well, what I'm going to do is I'm just going to change these to be title, price, and num seconds. So you'll see that my parameter names are the same as my instance data variable names. So I still need a way to assign this value to this variable. And so what I can do to distinguish between them is I can use the this keyword. So when I say this.price, the this.price is the instance data variable, and just the price with no this dot is this one here. It's the formal parameter. Okay, so this.title is the instance data variable, and just title is the formal parameter. Now, you are not required to do this in your code. You're not required to use the same names for your parameters as you are for your instance data variables. If you want to continue to use different names, that's totally fine. But you should be able to recognize and interpret if someone else uses the this dot structure. So you should be able to know that this dot, a variable name, means it's the instance data variable. Okay, and without the this dot, it just means whatever the most local variable is, which if there's a parameter with that name, then that's the version it refers to. So again, you don't have to use it. You should be able to interpret it if other people use it. But I do encourage you to use it because it's more conventional. It's convention to see the names be the same in the parameter list as they are in the instance data variables, and then just to use the this dot to distinguish them. So this is the convention that I'm going to follow, and I'm going to use this in my programming from now on. Again, you're not required to use it, but I do encourage you to use it, and you are required to be able to interpret it. So I'm going to use this approach in my constructors and also in my setters. So instead of having this parameter be called the new title, I'm just going to call it title, and then I'm going to distinguish between the two by the this dot. Same thing here. Instead of calling it the new price, I'm just going to call it price. And then I'm going to distinguish with the this dot. And the same thing here. So technically, you could always put the this dot everywhere you have an instance data variable. So I could add the this dot into my toString method. That'd be totally fine. I could add it into my get title because this is just means that we're just referring to the instance data variable. So it's always right to use this dot when you are referring to your instance data variable. But in most cases, it's not necessary. So the only time you have to use it is when you need to distinguish between a parameter and an instance data variable. But you're welcome to use it anytime. So you always can use it. But the only time, again, that the compiler requires you to use it is when there's two variables with the same name, and then the this dot is how you differentiate between those two. But you will see some people's code, you always use the this dot in every instance. And if you want to do that, that's totally fine. Okay, so I'm also going to update my audio store account in the same way. Okay, so again, it's usually, you do this right from the beginning. So you wouldn't be typically going back to make changes. It's just you'd program it this way right from the beginning. And again, I could say here, this dot balance, this dot items purchased, this dot name, all of that would be totally fine to do. I'm not going to do that. I don't typically do that in my programming, but it's totally acceptable, and you will see plenty of people who do that. One thing to be careful about is in your setters where you do have validity checks, you always want to be checking the value, whether the parameter value is valid, not whether the instance data variable is valid. So if there's a validity check there on the parameter, make sure that, again, you're checking just the parameter without the this dot, not checking the instance data variable. Okay? All right, so that is one use of the this keyword, is again to distinguish between instance data variables and formal parameters. The other way that we use the this keyword is to invoke an overloaded constructor. So what we're going to do first is we're going to write an overloaded constructor for our audio item class and our audio store account classes using some default values, and then we'll see how the this keyword comes into play. So first of all, we don't have any default values, so we need to define some. So we might say that a default value for an audio item is that the price is 99 cents. Let's say we know at our store that 90% of the things we sell cost 99 cents. We might say, okay, well, when we're creating new items, 90% of the time we don't want to have to specify that that's the cost because it's the cost a lot of the time. So we just want to be able to use a default. So what we can do is, remember, whenever we're using literal values, so numbers or text, it's a good idea to declare a constant. So I'm going to declare a public static final, and you can ignore the static in a minute. We're going to actually cover that shortly. Double default price is 99 cents. Okay, so this is going to be my default price for audio items. And again, I'm storing it as a constant. Because it's a constant, it's okay to make it public because the value can't be changed by later in my code anyways. Okay, so now what I'm going to do is I'm going to overload my constructor. And again, overloading means I'm going to give a second method that has the same name but differs in the parameters. So what I want to do in this constructor, I'm saying I'm allowing a user to set up an item by specifying all the an audio item by specifying all the information, specifying the title, specifying the price, and specifying the number of seconds. But I also want to give a user the way to specify an audio item without telling me the price. And if they don't tell me the price, I'm going to assume it's the default price. So the header for that would look like this. So here I'm saying, all right, one way again to set up an audio item is to give me all the information. But another way is to just give me the title and the duration. And if you don't give me a price, I'm just going to assume I'm using the default price. And this is a nice thing to do, right? Because you're giving your user of your class options. And this is user friendly to say, okay, sometimes I want to give you all the information, but sometimes I just want to use the defaults. Okay. So this is an example of overloading a constructor. Now I haven't written this constructor yet, but you can see that they have the same name, they're both constructors, but they differ in their parameter list. This one takes string double int, and this one takes just string int. Okay, now if I were to start to implement this constructor, I might start to do something like this. This dot title gets title, this dot num seconds gets num seconds, but then I should be thinking to myself, wait a minute, I've already typed this code. I don't want to retype this code. I never want to retype code. I never want to type code a second time that I've already typed the first time. What I can do instead is invoke a method that contains that code. So what I really want to do for my second overloaded constructor is I want to say, hey, let's just call this first constructor. I already wrote all this code. And what I can do is I can send this title into this constructor. I can send this num seconds into the constructor. And then I can send the default price. So what a lot of people are tempted to do is this. It looks like that would be a way to invoke this method from this class, but this just actually isn't the syntax that Java gives us. So this is the idea of what we're doing, but the way we do that, so the way we invoke a constructor is just with the keyword this. I don't know why. That's just what Java decided. Okay, they probably could have given it a different keyword, but they didn't. This is what it is. And it does kind of make sense, right? Because this is the current object. And remember that constructors are how we set up objects. So invoking this is basically saying, hey, set up this object. I don't know. You can decide whether or not you think it makes sense. But regardless of whether you think it makes sense, that's how it works. So that's the way we do it. When you want to call one constructor from another, again, what you do is you use the keyword this as if it's a method call, and then you send in the parameter list. So this is going to call the version of the constructor that takes string double int, which is this version here. And it's going to send this title in here, this default price in for the price, and the number of seconds in for the number of seconds. And then this whole constructor is going to be executed line by line, just like it would if it were invoked directly. Now, this is always a good way to set up constructors. The reason is that in this case, there's only 3 lines in our initial constructor. So if we had to retype those lines, it wouldn't be that bad. But your constructors can get a lot more complicated. You might have lots of variables that you're initializing, or you might have some other code here that does some other more complicated things, like, I don't know, set something else up about this audio item. And as you put more and more code into your constructor, it's more and more things that you're going to have to duplicate. You also might have not just 2 constructors, but maybe you'll have 5 constructors. And if you have 5 constructors, even rewriting 3 lines 5 times is a lot. So it's always a good idea to fully implement or write out the constructor that takes in the most information from the user, and then just invoke that constructor from the overloaded constructors. And one more note about this. Remember I said this has to be the first line in the constructor. So if I were to try to put another line of code here, whatever it is, I would get a compiler error. Okay, so if you're going to call another constructor, it has to be the first line in the code in that constructor. Okay, so let's also overload our audio store account. And here probably doesn't make sense to have a default name or a default account ID. That probably doesn't make a lot of sense, but it might make sense to have a default balance. So let's create a constant default initial balance, and I think it probably makes sense to create an account with no money in it. So that's how we will define our constant. And so this is our first constructor. Let's overload our second constructor. So here we have a second constructor that just takes in the name and the account ID and not a balance. And then what I want to do is I want to call this, invoke this version of the constructor. So I do that with this, and I send in name, which is this one here, the one taken as input. I'm now passing to this constructor here. Account ID that's taken as input and now passed to this constructor here. And then what am I sending in for the balance? I'm sending in the default initial balance. And there we go. And now here's another example of, again, why it's a good thing to call this other constructor, because here not only did we initialize those 3 instance data variables, but we also have this line of code of setting up our purchased items list. We wouldn't want to have to repeat that either. So here's just, this constructor is a little bit more complicated, and because we invoke it than the last one we looked at, and because we invoke it, it's just less code that we're needing to repeat, which is a good thing. Now you might also notice that now our audio store account has no way to add money. It probably would be a good idea to add money. We do have the set balance method, so we can use that, which is good. Okay, so now let's just actually invoke some of these constructors. So I'm going to go back up where I'd created some audio items. And here I'd created an audio item sending in 3 parameters. So this is invoking the 3 parameter constructor, the one that takes string double int. Let's create another audio item song. We'll do a classic, Over the Rainbow, and let's say it's, I don't know how long it is, let's say it's 240 seconds long, but I'm not going to specify the price because this uses the default price. So this invokes the 2 parameter constructor and uses the default price. Okay, so just like anytime we invoke an overloaded method, we know which constructor to invoke, by matching up the parameter type. So this is going to invoke the constructor that goes string double int. This is going to invoke the constructor that takes string int, which is this one here, string int. And once we get in here and start executing that constructor, we see that the very first thing we do is we're going to call this constructor that takes string double int. String double int. Okay? So that's an example of overloading constructors, using the this keyword to invoke the overloaded constructors. And then we also looked at how to use the this keyword to distinguish between instance data variables and formal parameters.